Okay, so this time we're going to discuss about the software evolution. No? The course intended learning outcomes of this module are to explain why software evolution is an important part of the software engineering and to describe software evolution processes. Now, when you have, of course, when we discuss, we will be able to understand the change is inevitable. No, if software systems are to remain useful and that software development in evolution may be integrated in a spiral model. We understand software evolution process and influences on these processes. We have learned about different types of software maintenance and the factors that affect maintenance costs and understand how legacy system can be assessed to decide whether they should be scrapped, maintained, re-engineered, or replaced. Software development does not stop when a system is delivered, but continues throughout the lifetime of the system. After a system has been deployed, it inevitably has to change if it is to remain useful. Business changes and changes to user expectation generate new requirements for the existing software. Parts of the software may have to be modified to correct errors that are found in an operation. To adapt it for changes to its hardware and software platforms and to improve its performance or other functional characteristics. Software evolution is important because organizations have invested large amount of money in their software and are now completely dependent on these systems. Their systems are critical business asset and they have to invest in system change to maintain the value of this asset. Consequently, most large companies spend more on maintaining existing system than on new system developed. Based on informal industry pool, organizational software costs are evolution costs. Other surveys suggest that about 85 to 90% actually, the cost of software change are a large part of the IT budget for all companies. Software evolution may be triggered by changing business requirements, so by reports of software defects or by changes to other system in a software systems environment. It have, of course, software development is described situation in which software system have to be developed and managed in an environment where they are dependent on many other software systems. Therefore, software evolution or the evolutions of a system can rarely be considered in its isolation. Changes to the environment lead to system change that may then trigger further environmental changes. Of course, the fact that systems have to evolve in a system's rich environment often increases the difficulties and cost of evolution, as well as understanding and analyzing an impact of a proposed change on the system itself. You may also have to assess how this may affect other systems in the operational environment. Useful software often have a very long lifetime. Let's say, for example, large military or infrastructure systems such as air traffic control system may have a lifetime of 30 years or more. Business systems are often more than 10 years old. Software costs a lot of money of an organization has to use a software system for many years to get a return on its investment. Obviously, the requirements of the installed system change as a business and each environment change. Therefore, new releases of the system incorporating changes and updates are usually created at regular intervals. You should therefore think of software engineering as a spiral process with requirements, design, implementation, and testing going on throughout the lifetime of the system. You start by creating release 1 of the system. Once delivered, changes are proposed and the development of release 2 starts almost immediately. Now, in fact, the need for revolution may become obvious even before the system is deployed, so that later releases of the software may underdevelop before the current version has been released. And this model evolution, software evolution, implies that a single organization is responsible for both the initial software development and the evolution of the software. And most package and software products are developed using this approach. For custom software, now a different approach is commonly used because a software organization develops software for a customer and the customer's own development staff then take over the system. They are responsible for software evolution. Alternatively, the software customer might issue a separate contract to a different company for a system support and evolution. If you are now using an iPhone, no, almost a month, no, they have an update with their operating system, right? So in this case, no, there are really to be continuities in the spiral process. The requirements and design documents may not be passed from one organization to another. Organization may merge or pre-organize and inherent software from other companies, and then find that this has to be changed. When the transitions from development to evolution is not seamless, the process of changing the software after delivery is often called software maintenance. As we discussed, no, maintenance involves extra process activities such as program understanding in addition to the normal activities of software development. So I just want to play this video presentation.
Welcome students. Today we are going to start with a new topic, that is software evaluation. It is inside your module 4, the second part. So from here you can get some 2 questions. Okay, that also we will check it out what kind of questions you are going to get in your exam. Before that, let's understand what do you mean by software evaluation. So it is a term. Okay, the first thing is it is a term, and also it is a process. Okay, so why I have called it as a process? Because we are going to develop some of the software initially. Okay, we have been developed some of the softwares initially, then timely, by according to your customers expectations, we are going to change the software due to some various reasons. So what we are going to change in the software? We may add some new features, or we may add some of the functionalities, and we can make any kind of changes according to our customers, right? So due to that, the proposed new changes, whatever we have done, so that if it has been accepted by the customer, then the new release of the software will be planned. Okay, so when we have planned with the new release, that is nothing but we have evolved or we have come up with the new software. So here we will have some of the process, as I told you first only, that we have called it as a process, because we have some 4 steps. The first step will be we have to identify or the process how we are going to make the changes. Fine. So once we have done with the changes, the next step we are going to put the proposal that yes, this kind of changes we are going to do it. What will be in your third step? We have to the software evolution process, where we are going to find out the changes and we are going to implement it. Then the fourth step will be we have come up with a new system. So this process, that is nothing but according to our customers expectations, we are going to change the software and we have to come with the new, or we have to evolve the new software, right? That is nothing but that is your software evolution. So let's go to the first slide. Here you can see what are the topics we are going to cover for this chapter. So the first one will be the evolution process, and the next one will be your legacy system, and the last one will be your software maintenance. So these 3 topics we are going to cover. But for today's class, we are going to cover only the first one, that is your evolution process. So now we have to understand what do you mean by evolution process. Okay, so let's move to the next one. Here you have to see the first slide tells you about the software change, how we are going to make the change inside our software. So what do you mean by software? So this software is nothing but it is a program code. Everybody knows that, right? And what do you mean by program? A program is an executable code which has to be served according to your computational purpose. Whatever purpose you have given, according to that, the program has to be a executable code. And also this software is nothing but it will be a collection of your programming code and also some of the associated libraries and also some of the documentations. So whenever all these things we have made as a specific for a specific requirement, that time we can call it as a software product. Okay, our main aim will be to find the changes or to have the changes inside the software product. So one more thing will be what? The engineering process, right? How we are going to use that process to have the changes in the software. So what do you mean by that engineering process? You have to develop the product and then you have to define it properly with some of the scientific principles and the methods and the algorithms, techniques, all these things, and then you are going to implement it, right? So that is nothing but that is your software's product, how you are going to use in your software engineering. Now once we have done that, because we have already studied about the waterfall model, many models we have already studied. So now if I am going according to that, maybe my customer wants that some changes in the future, how I'm going to overcome that changes and how I'm going to produce that changes. Okay, so here the software evolution will be nothing but, as I told you already, it is a software product. Okay, the first thing is it is a software product, and which will have some of the algorithms, technologies, and it will be prescribed towards your software evolution. And also it will have some initial development. First, what we have done in your waterfall model, requirement and in requirement gathering, right? So there we have to collect some of the requirements which has to develop your, which will be useful to develop your softwares, and also it will helpful for you to maintain the software. If you have done any updates for the software, that also has to be maintained properly. Now the question is where we are going to have the changes in the software, right? So here you can see the slide belongs to that only. Wherever you want to have the changes can be made. Suppose if you have student database and you have only name and phone number and all, and now you want to add the email address. So when the customer has seen that product, he told that no, I don't like this, I want to be added with the email ID. So what you are going to do? You have to make the software changes, right? So that time the new requirements has to be added over there. So that will be your new requirement changes. Now what will be the next one? The business environment. The business environment also can be a parameter to change the softwares. Fine. Then the next one will be the errors. Okay, if you have got some bugs or something and you want to repair it for the further ahead communications and all, so that time that errors also has to be taken care properly. And the next one will be your computers and equipments has to be added. Suppose if you have some versions of computer, you want to update it, so according to that your software also will get changed. So in that way you have to add the equipments whatever you want according to your new softwares. Then the last one will be the reliability. What do you mean by reliability? It's the performance, the bandwidth, the latency, whatever we have provided to improve our software, that has to be maintained properly. Because if we have given the performance and reliability properly, then only the like if we have given proper bandwidth, latency, then the performance will be much more better than the previous one. So these are some of the key problems which used to happen in the organization while implementing and managing the software system. Okay, so this is nothing but the first slide of your software change. Now let's see what all are the importance of evolution. Okay, why it is important? It is really very important because it has to work or act according to our customer. So the first thing is the organization will have the huge investment for this software system. Okay, and as they have done the huge investment for any of the software product, then definitely that will be the business asset for them, and if any loss will happen, they can bear that. That's the reason it will be a huge investment for the organization. Now the what will be the next assets will be to maintain all these assets. Okay, with the business and all, if you want to have the changes or if you want to go for any updates and all, then it has to be properly taken care. Okay, the major budget will be for your large companies, which where they have to evolve with the existing software also. And if they, with the existing software, if they want to bring some of the, or if they want to add some of the new functionalities with that software, that also has to be taken care. So these all are the importance of your software evolution. And also in this you can see that even after using, all the users, they will have the desired softwares right in hand, but we have some advanced technology and the changes in the requirement force which will help our software products to change accordingly, because we have already some of the existing, as per this last point. And with that, if we have some advanced technology, then definitely the software will get changed. And also after recreating all these softwares from the scratch and then go on one by one with the requirement, it's not feasible, it's very difficult to do. So that's the reason always we should have the existing software which will be very feasible to utilize. And also the if I'll consider the economical way, that also will give us the within the budget, and also we can update the existing software which will match with our latest requirement. That is the reason we have come to towards your evolution, and these all are your importance of evolutions. Moving towards your next slide, you can see here one spiral model, right? So what is this spiral model? Already we have gone through this spiral model in our last times and all. In the first classes we have seen all these things. Now let's see once again how the spiral model is utilized, is will be helpful for us in developing and evaluating the softwares. So if I'll consider about the release one, so what will happen, how the spiral has to work, it has to work like this, right? So first you have to gather all the specifications, requirements and everything. Then you have to go for your implementation part. Once implementation part will be done, go for your validation, then operation and maintenance. That is the last step. If suppose you found that no, we have to make some of the changes, then in your release 2, you have to again gather the requirements and specifications, go for again implementation, validation, and again you release the software. After that also again, if you feel that no, again I should have some of the changes, then multiple times you can have the changes inside your softwares. So that is nothing but that will be your spiral model in your developing the software products. And also you have to remember that what all are the programming paradigms are there, where they will be the subset of your software design. This is a software design, right? They will be the subset of this software design. And also what they will do while developing this software paradigm, they will be helping us in providing all the requirements. So this is also known as your software engineering paradigm. That also we have to remember. So here these three things we have seen, like in our software product, whenever we are building the software product, first of all we should gather the requirements, then we have to design the software, then we have to go for the implementation part. But what will happen inside the software design paradigm? You have to design the software, you have to go for maintenance, and then you have to go for your programming things. Okay, inside that programming again you have to go for your coding, testing and the integration parts. These all are will be a spiral model of your developing any of these softwares. Now moving towards the next slide, here you can see how the evolution process is taking care and the servicing process will be taken care. So now in this, the first one will be your software development. Once the software development has done, then you can go for the software evolution, and then you can go for the software servicing. Then the last one, you can go for the software retirement according to your timeline, right? There will be a specific timeline from the customer side, and how you're going to provide the software towards the customer side. You need to have the development first, then you need to go for the evolution, then you need to go for your servicing, and in the last part, you have to go for the retirements. So this is the servicing part of your softwares. Now how, if I'll go the step-by-step process, now how the evolution and servicing part is working out. Now you can see the first one will be your evolution part, where there will be the stages, right? The stages. What is the first stage? Already I told you that we have the life cycle, that is spiral model life cycle is already there. software system lifecycle is already there, which will be helpful for us to create all these things and to be useful for as a operational. And also if we have some of the new requirements, it can be proposed and it can be implemented in the system. So this is nothing but just the evolution of your softwares. If you have any new requirements, how you are going to deal with that. In the next step, you can see the servicing part. What is happening in your servicing part? This is again in the next stage. So here the software will be remain useful, but the only changes you have to do if you want to make it as operational. Example, if you want to fix the error, or if you want to make some changes for your software environment or for your software platforms, then that time you have to go for the servicing, because you need to update your software. No new functionality you are going to add if you are going for the servicing, because the servicing is nothing but it's only whatever the software you have to check the errors, and if any updations you want to do, just you have to do the updations. So for this stage you should not add any functionality for the servicing. What is the last one? That is phase out. So here what will happen, if the software is still in use, or if you don't want to make any changes and all, then just you go for the next stage. Okay, so this stage is nothing but just you check it out that in what way your software is available. So now next we have come to the first point of evolution process, which in detail we have to see. So now we have to see the evolution process. If I'm not wrong, there will be some 6 points. Okay, and just remember, this evolution process can come for your 8 marks of question. The question will be, with an appropriate block diagram, explain the system evolution process, which already came in last years and all. So there are some 6 points you have to remember, and you have to explain the software evolution process. So what is now the software evolution process? The first thing you have to remember that it is dependent on the type of the software and how the development processes has been utilized, and then the skills and the experience the people has been involved to make this software. So here, if you want to build any software properly, you should have some of the things, right? The software evolution should be dependent on something. What is that? The first thing is what kind of software you are going to make, right? The next one will be how you are going to utilize the development process, which model you are using to develop your softwares. Then the last one will be the skills and the experience of your resource persons, those who are involved inside your software process, right? So these all are some of the evolution process. It depends on. The next step, you can see the proposals for change are the driver for system evolution. It means that what are the how it is going to be linked with the components or some of the new functionalities which is going to be affected on that. If I'm going to make any changes in the like a software, then how it will be impacted towards my software process. That has to be taken care over here if I'm going to give the proposals. It means that once again, like suppose if you have already built a software and you have some budget limit, and if you have gone for some again the changes in the softwares, and if you have added some of the new functionality and the components inside that, then you have to have the clear picture that how you have bear with the cost and the impact once the changes has been made, and that estimation also you need to provide to your customer. And if they are satisfied and agreed, then you can go for the new proposal system. Then the last point will be the changes, the identification and the evolution continues throughout the system lifetime. It means that I have showed you already the spiral model. What happened in that? Once the release 1 has done, if you are not satisfied with your release 1, if you want to add some of the new features into that, you can go for your release 2. So multiple times the changes can be occurred inside your program, and you can evolve the continuation process in many times throughout the lifetime system. So now you can see one diagram here, that is a change, identification and evolution process. What's happening here? It is like a spiral model only. Here you can see first you have to identify the process, how you are going to bring the changes inside your software development, like software development. Next, you have to put the proposals about your changes. Then you have to move towards the software evaluation, because you have to show here that if you have made this kind of changes, then how it has been impacted towards your old system and how it is good, or how you can compare with your old system. Then you have to build your new system after the proposals if it has been agreed. Then if again you are not satisfied or the customer is not satisfied, you can continue the same process in multiple times. Now here you can see the software evolution process life cycles, how it has gone. So first the change request has to be built. Then once a change request has given, then you have to go for the impact analysis. You have to find out the cost and impact towards your system. Then you have to go for the planning, where you have to release the planning, and if it needs any changes, you have to go for change implementation. If it doesn't need any changes, then you just go for the platform, in which platform the software has to run. So you need to adopt that platform. And again, that is also in three types. One is there, like just you adopt the platform whatever is available. Next, suppose if you want some enhancement, you can go for the system enhancement. And one more will be like, if you don't want that, you want the repair or you want to fix the bugs, then also you can go for another layer. Okay, once all these things has been done, you can go for the system release. And as I told you, it comes under your like a spiral model. So it has to come over again here, and it is going to work out in that way. So that is nothing but that is your software evolution process. Now, if I want to bring any change implementation inside my software, then how I'm going to work out in that? The first thing will be I have to gather some of the, first I have to find out the proposed changes. So once the proposed changes has been reached, I have to analysis on that. And if I want to have some requirements in that, then I will have here itself. And again, if you want to change some proposal system, you can move towards again, or else you can update it and then you can develop your software. So this is a implementation process of your change if you are going to made inside your software. So now here you can see whatever I have told you. The iteration of the development process, where the revisions to the system are designed, implemented and tested. It means that iteration in the sense repetition process. You know that it is a spiral model, so the repetition will be there. Okay, so whatever you have designed or implemented, or you have done the coding part, or you have done with the testing part, every time it needs the repetition of the process. So that is the meaning of your change implementation. And what is the difference in between the stages? In your first stage, you have to change the implementation, which is already involved inside your program understanding. And also it is a system developer which is not responsible for your change implementation part. It means first you have to involve into the program understanding. You need to understand what is the software is all about and how we are going to bring into the notice that yes, if I have utilized the original one, what will be my outcome, and if I have made some of the changes, then what will be my outcome. So in all these cases, the system developers will not be responsible if you made any changes inside the program. And inside the like program understanding phase also, you need to understand how the programs are very structured and how you are going to deliver with the functionality and how you are going to propose the changes, so which will affect your program. That also has to be taken care properly. So now what all are your urgent change requests, how you are going to work if you have some requests, how you are going to deal with that. So here, without going through all the stages, suppose if your software needs any urgent changes, then directly you have, if you have found that it is a system fault, then you cannot wait for anyone, right? So you have to go for your repair stage. Directly you can go for your repair stage, and you have to allow the normal operations to continue. You cannot wait in that time, because sometimes the urgent changes will come, right? So that time you cannot wait in that. Whatever the changes required, you have to do in a normal process. And if suppose you want the changes urgently in the system's environment, like any operating system upgradation and all, and they will have the unexpected effects, right? So that time also you can go for your urgent changes. And suppose if you have some business changes and some rapid response you have to gather at a time, then you have to release the competing products and you can gather all the rapid responses. So this is all about your urgent change request term. Now how to go for your emergency repair process? First the changes request will come, then you have to analyze the source code, how we can make the changes in the request, then you have to modify the source code, and then you just deliver the modified source code. In this way the emergency source repair process will work out. Next, we have some agile methods and evolution. I already told you the agile methods is nothing but it is an incremental process, right? And also incremental process in the sense, first step you have to complete, test it properly, then you go for your next step and then again you test it. That's the reason it is known as your incremental development process, where you will have the transition from development to the evolution. Okay. So here the evolution will be a continuous development process. Fine. So here once you have done with the changes and everything, you just go for the tested. Once the tested has done, go for the next step. And here which kind of testing process we are applying? We are going for the automated regression testing process, which will have the valuable method to change our system. Then the next one will be the changes which has been expressed as additional stories. So here, if you have some additional changes, that also you can go for. Next, what will be the handover problems? What normally we will have some problems. Here, what will happen is wherever the development team will be there, and some of the companies they will be using the agile approach. Okay, so if they are using the agile approach, they should know what is the development team should know what is the agile approach. But somewhere, some companies, what will happen is the evolution team will not be knowing about the agile methods and how it is going to be work out. So they want a plan-based approach. Okay, someone has to tell them that yes, you need to go for in this approach, then only you can provide the best into that. So that time what will happen, the evolution team can expect the detailed documentation process, okay, from the development team if they don't know about the agile process. And suppose if they are going for the plan-based approach, then what will happen, then the development and the evaluation team both has to refer the agile methods, because they have to start all the program codes and everything from the scratch itself, and then they have to go for the automated regression testing progress for all the codes and all. Then they have to refactor everything and then they can simplify the expectations. So this is a very huge task for your evolution team to do. So if they are going for a agile process, then what will happen, one plan based approach will be there. The evolution team will make them to understand what to do and all, because they will have the documentation, codes, everything to support the evolution team. So this kind of problems sometimes arise inside your while dealing with the development team and the evolution team. So the next class we are going to have this legacy system. So for today's class we have done over here, so that is about your evolution process. I have explained you the types of your evolution process. If you want, you just note it down also. In the first stage you have to bring the changes, that is
Okay, to sum up the discussions of this topic, no, the software development and evolution can be thought of as an integrated iterative process that can be represented using a spiral model. For custom systems or customized system, the cost of the software maintenance usually exceed the software development cost. The process of software evolution is driven by requests for changes and includes change impact analysis, now release planning, and change implementation. Lehman's law, now such as notion that change is continuous, describe a number of insights derived from long-term studies of system evolution. There are three types of software maintenance, no, namely bug fixing, modifying the software to work in a new environment, and implementing new or changed requirements. Software engineering is concerned with restructuring and redocumenting software to make it easier to understand and change. Refactoring, making small program changes that preserve functionality, can be thought of as preventative maintenance. And lastly, the business value of the legacy system and the quality of the application software in its environment should be assessed to determine whether the system should be replaced, transformed, or maintained. Okay? So I think that's it for software revolution.